Last week we learned how to complete ordered pairs, and in section 3.3 we're going to be completing ordered pairs and then using those to actually graph a line. So the first step is to do what we did last week, where we take the given value. In this case, for the first one, we have a value of 0 in the x place. We're going to plug that in to the x in the equation. So we get 3 times 0 minus y equals 5. 3 times 0 goes away. We're left with negative y equals 5. Divide by negative 1. Divide by negative 1. And we get y equals negative 5. Okay, now we do the same thing for the next problem. I'm going to change ink color here. Now we've been given 0 for y, so we plug 0 in for y, and we get 3x minus 0 equals 5. The 0 goes away. We have 3x equals 5. Divide by 3, and x equals 5/3. All right, the last one, we're given another y. This time y is negative 6. So we plug negative 6 in for y. We get 3x minus, now be careful here because you're inserting a negative 6 and you're subtracting. So that means you have a double negative. So this becomes positive and I get 3x plus 6 equals 5. Subtract 6, subtract 6, and we have 3x equals negative 1, divide by 3, and x equals negative 1/3. Okay, now notice a few of these have fractions, so we're going to be graphing in between each of these marks. So it's not going to be landing right on one of these lines. Instead, it's going to be in between. So this will be good practice for that. Okay, so we did the first part, complete the given ordered pairs. Now we're going to graph the results. For the first point, we have 0, negative 5. So we start at the origin, 0, and we go down 5. 1, 2, 3, 4, 5. So that is our first point, and I'm going to go ahead and label it as 0, negative 5. The next point is 5/3, 0. Well, 5/3, 3 goes into 5 one time with 2 left over. So this is the one time you're going to see me write a mixed number. Oops, I have to change the font on that. So I'm going to get 1 2/3. Okay, that equals 5/3. I'm doing that because it will be a little bit easier to graph. The other way is to convert that to a fraction. You can also do that, or sorry, to a decimal also. That will help. Okay, so I move to the right 1, and then I need to approximate 2/3. Well, this is approximately 1/3. Okay, this is approximately 1/3 right here, so approximately 2/3 is right here. And then notice we're not moving anywhere vertically because y is 0, so this is my point. So I'm going to go ahead and label that, and I'm going to label it using the improper fraction. So I use the mixed number to help me in graphing, or the decimal, but I always label my points with the improper fraction. All right, the next value is negative 1/3 and negative 6. So now I have to move to the left. And again, this is approximately 1/3. And then I have to go down 6. 1, 2, 3, 4, 5, 6. Approximately, okay? And then I go ahead and draw or label my point. All right, now this is a line, so all of my points should fall on a line. I'm going to pull out my straight edge and do the best I can drawing this thing. Again, It's kind of approximate. Whenever you have fractions, you're going to end up with approximate. That line should be traveling exactly through all of those points. This is the challenge of the surface and the inking capability, but that is the line that is created from finding those ordered pairs from the equation. And so we would say that this line models this equation. Okay, so let's try this on the next one. Okay, this is asking to do the same thing as the previous slide, and it said complete the given ordered pair and graph the results. So again, we're going to go through the process of plugging in the values that we have and finding the missing values, and then using those coordinates to graph. All right, so for the first one, we're given that y equals 13. So we have 13 equals 3x minus 5. So I'm taking this value and plugging it in for y. Now I have to add 5, so now I have to isolate x. So I get 18 equals 3x. I divide by 3, and 18 divided by 3 is 6. And that equals x. So that is the other value in that first coordinate. Okay, now I'm given 0 for x, so I plug 0 in. I get y equals 3 times 0 minus 5. Well, 3 times 0 is 0, so that goes away. And I'm left with y equals negative 5. All right, the last point, I'm given an x again, and I get y equals 3 times negative 2 minus 5. Y equals negative 6 minus 5. And y equals negative 11. Now this one may introduce an issue which on an exam I'll make sure doesn't happen, but where we need to change the scale of our graph to make sure that all of the points fall on the line. So notice this last value is negative 11. Well, if I count how many spots I have 1, 2, 3, 4, 5, 6, 7, 8. It only gets to 8. So if I have a scale of 1. So if I change that scale to 2, so I'm going by 2's instead, and I can do that on my y-axis, but keep my x-axis as 1, that will go ahead and make it large enough. So I'm going to go ahead and do that. So I'm just going to label here that this is negative 2, negative 4, negative 4, and then it will continue negative 6, negative 8, negative 10, negative 12, negative 14, negative 16. So my upper one on the y-axis will also be by 2. Okay, and then on my x-axis, it's going to be by 1. So anytime you have a point, well, first of all, anytime you have a coordinate system that isn't labeled with an axis, and then you have a point that falls outside of the graph that you've been given, if you're using a scale of 1, then you can go ahead and change it. So that's what I've done here. Okay, so now we're going to go ahead and graph. Now, in order to graph a line, you have to have at least 2 points, but notice we're always graphing 3 points. That gives us a much better chance of not making a mistake, because if you graph 2 points and then graph a third point and that doesn't fall on the line, it means that there's been a mistake in there. So I would always recommend graphing 3 points. Okay, so I'm going to go for my first point. 6 and 13, I'm going to go to the right 6. 1, 2, 3, 4, 5, 6. Here's 6. And then I'm going to go up 13. And remember, the scale is going by 2. So I have 2, 4, 6, 8, 10, 12. So 13 falls in the middle here between 12 and 14. And I'm going to go ahead and label my point. All right, the next point is 0, negative 5. So 0, I'm not moving anywhere horizontally, and I'm going down 5. So I do 2, 4, then again 5 falls between negative 4 and negative 6. So I'm going to go ahead and label that, and I get 0, negative 5. Okay, the last one is negative 2, negative 11. Again, my scale on the horizontal is 1, so I go negative 1, negative 2. There's my negative 2. And now I go down to negative 11, but the scale is 2. So I do 2, 4, negative 2, negative 4, negative 6, negative 8, negative 10. So negative 11 falls right between negative 10 and negative 11. So that is my next point. And again, I'm going to label that negative 2, negative 11. Now, these do land on a line, which means I've graphed it correctly. But again, due to my technology here, it may not graph very accurately, but we'll do the best we can. That was better than the first one. Okay, so that is the graph of the equation y equals 3x minus 5. This is asking us to do the same thing as the previous slides in terms of completing the given pairs, but notice here it says that y equals 2. This is one where we have no values to plug into it because we don't have an unknown like an x. But instead, every point should have a value of y equals 2. So we just need to put 2 into the first point to complete that pair. Then we put 2 into the second point to complete that pair. And finally, we'll put 2 in for the third point. And again, this is just saying that for every point, y equals 2. So now we need to go graph. Okay, so here we have, and I'm just double checking the size of my values. I have a negative 8, which is my biggest value, and I'm going to make sure I have 8 spots basically that I can count. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have enough that I don't have to change the scale like I did on the previous problem. Okay, so the first point that I'm going to do is 5, which is my x. So 1, 2, 3, 4, 5 is right here. And notice I'm not putting a point there because that is not part of my graph. I'm just marking it so that I know that's how far to the right I've moved. But to finish the point, I now need to go up 2. So I go 1, 2. And that is my final point. And I'm going to label it 5, 2. All right, the next point is negative 8, 2. So I go over to the left 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, I'm just going to mark it, but not put a dot. That's my negative 8. And then I go up 2. 1, 2. So my point is negative 8, 2. All right, my last point is 1/2, 2. So I know I'm moving to the right because my first value is positive, but 1/2 falls between 0 and 1. So that is how far I'm going to move on the x, and then I move up 2 for my y. So 1, 2. All right, now just for clarity, I'm changing the color of the line, so it's going to be a little bit easier to see. But that is not something that you have to do, although on tests, as you're graphing, it can be helpful to use different colors. Okay, hopefully you can see this. And again, pretend that's straight. Technologically, it's just very hard to do really straight lines. But anyway, that is the line that models y equals 2. Here we're going to check whether points land on our line, but we're going to do what we did last week in terms of testing the points first and seeing if they're a solution, and then we're going to graph the points and actually check. So this is a combination of two things that we've done up to this point. Okay, so the first thing I'm going to do is check the points. So the first point to check is 2, 3. So I'm going to plug 2 in for x and 3 in for y, and I get 10. I get 4 minus 15 equals 10. Well, negative 11 does not equal 10. So that is not a solution. Okay, the next one is 2 times 0 minus 5. Now be careful of this. I'm going to draw a line here just so it's clear where one problem ends and the other begins. Minus 5 times negative 2, right? That's a negative 2 that you're putting in, equals 10. Well, 2 times 0 goes away, and a negative 5 times a negative 2 is 10. So that is a solution. All right, the next one that we need to do is our 5 halves comma 1, which I'm going to do over on the left-hand side. So I have 2, and because I have to put in a fraction for the x, I'm going to write that as 2 over 1. It's not a required step, but it's easier for me to see what I need to do when I'm multiplying, dividing, adding, or subtracting fractions. And then I have minus 5 times 1. Okay, so I have the 2's go away. Oh, and that equals 10. So the 2 goes away, and I get 5 minus 5 equals 10. Well, 0 does not equal 10. So neither of these fall on the line that's modeled by 2x minus 5y equals 10. So I'm going to go ahead and graph these. And this is an example of why graphing more than 2 points is valuable. That's really a key reason why I'm doing this step. The first thing I'm going to do is graph my 2, 3. So 1, 2, and then up 3, 1, 2, 3. Okay, so that gives me 2, 3. All right, the next one is 0, negative 2, so down to negative 2. 0, negative 2. Now, if I just left it at those 2 points, I would say, oh, that is the line that models the 2x minus 5y equals 10. But I need to graph that third point to see, do all of the points align? If they don't, then something, at least one of them doesn't fit. And as we calculated, we know in fact 2 don't fit. Okay, so I'm going to graph the 0. No, I'm not. I'm going to do the 5 halves and the 1. I already did the 0 and negative 2. So 5 halves. 5 halves is the same as 2 and 1/2. Again, I'm just doing that to help me with my graphing. So I go over 2 1/2. That's right here. And then I go up 1. And notice that does not fall on a line. And therefore, I know that at least one of these values do not meet the 2x minus 5y equals 10 model. All right, I'll move on to another example. Okay, we're going to do the same thing on this problem as we did on the previous problems, where we're algebraically going to check our the solutions and see which ones fall on that line, and then we'll go ahead and graph them and see how that corresponds. Just for clarity, I'm going to add a little semicolon after the 6 to show that that is the end of the equation and the next values are the points. All right, so to begin, I have negative x plus 3y equals 6. And I need to plug the negative 3 in for the x and the 1 for the y. Just a reminder, if you get confused as to which one goes where, it can be valuable to label the variables above, because the x will always come first and the y will always come second. All right, so the negative, and that's the negative on the x, so be careful about that. I plug in negative 3 for the x plus 3y equals 6. Oops. What did I do there? I need to plug the 1 in for the y as well. And I get 3 plus 3 equals 6, and 6 equals 6. So negative 3, 1 is a solution to the system. All right, so now I'm going to check the next one. I have 0 for x, so I get negative 0 plus 3 times 3 equals 6. Well, this becomes 0, it goes away, and I get 9 equals 6. Well, 9 does not equal 6, so 0, 3 is not a solution. All right, the last one, I'm going to plug my 4 in for y. No, I'm not. I'm going to plug my 6 in for the x, so I get negative 6 plus 3 times 4 equals 6. Well, negative 6 plus 12 equals 6. Negative 6 plus 12 is 6, so 6 equals 6. So that shows that this point is also a solution. All right, so now I'm going to graph the points, and I'm going to see whether all of those points fall on a line, and if they don't, then that will confirm that my calculations most likely were correct. Okay, so I have negative 3 and 1, so I go to the left 3, 1, 2, 3. Again, I'm not putting a point there. I'm just showing that that is how far I've moved on the horizontal axis. And then I go up 1, and that is my final point. So I have negative 3, 1 for my first point. My next point is 0, so I'm not moving anywhere horizontally, and I go up 3. 1, 2, 3. And my point is 0, 3. The last one is 6, 4. So I'm going to go ahead and count over to the right 6. 1, 2, 3, 4, 5, 6. Again, I'm just marking 6 there. I'm not putting a point. And then I go up 4. 1, 2, 3, 4. So 6, 4. All right, so if I draw a line between my 2 points here, as best I can. Okay, notice there's one point that does not fall on that line, and that's the 0, 3, which indeed is the one that we found to not be a solution for that equation.